recording. Um, you want to share your screen? Let's poke around. I was thinking more about. I was thinking we had. I got some. I'd liked last week we were looking at refactoring questions, right? Where it isn't necessarily like, sort of like how does this API work? Help me figure out this error message. It was more like, okay, I built this thing and like why isn't it working the way I wanted, or I saw it and it doesn't look, the way it doesn't look particularly clean. And I thought those were interesting discussions. Um, so yeah, that's my pitch for today's stuff. Um, you want to share your screen? I can't really see what you're typing.
Yeah, I was driving at what? So let me share. Let's do window. Let's go here. So we've got a choice here. I'm with you. The
Mm-hmm.
refactoring is a good idea. So we could go to Stack Overflow.
Mm-hmm.
We could find a refactoring or oriented question, or we could go to insert repo
We could
and
we could do what
and some
repo?
code. That's the question. Um, I'm sure we could find one pretty quickly. We can go pick apart Rails. We can go pick apart, a repo of your choice. I'm sure we can find some things to discuss.
You pick.
Yeah.
I don't know. I'm always excited to. Yeah, we could. I mean, if you want to go and we could pick something apart, I'd be very interested in that.
Yeah, that's the refactoring is the idea here, right? Let's just pick something. Um, let's see. And this is kind of at random. So,
All right.
controller. Let's find something. Oh, caching.
Oh, caching. Okay.
Okay, that was tiny. So there wasn't enough there to.
Well, okay. Hang on. Well, let's start with something tiny. Let's start with something easy, shall we?
Let's do it.
Okay. So,
Okay.
okay.
Right. Here we got a class.
Well, we don't have a class. We've got a module,
Oh, that's true. That's true. It's a module only.
right? And there's a module in a module.
So the outer module is action controller. So there, it looks like this is just acting as namespace here, right?
Mm-hmm. Mm-hmm.
Those things you can Ruby. This is it's not doing anything other than providing a namespace. And
Got it.
there's nothing wrong with that. This is important.
Yep.
So it looks like this outer one is just for namespacing.
Mm-hmm.
And then here they have documentation. They tell us what caching is.
Right.
Okay. They define caching. Fair enough. No, to turn off all caching. They give you some configuration option turned off.
Got it.
It's nice. Um, and they give us a group of different caching backends that can be used.
Mm-hmm.
Some configuration. Hey, here's any of the caching backends you can use. And if you include this caching, looks like you get access to any of these depending on how that's configured. This just provides you the access to it. Most of it is private.
Mm-hmm. And so, well, hang on. So let's see. So a couple things that I'm seeing, right? Like interesting stuff, right? So, I'm just looking to go through like 21 through 25. These are interesting stuff. These are interesting things here, right? In that, like, okay, for 21, you can do memory store, right? That's great. We keep our cache in memory, I think implicitly locally. Okay. Then we could sit back and say, did I see that file stores are default, right? So we're going out and we're writing out to the file system for a cache.
That is consistent by default.
That's an interesting default. I mean, just because the file system's kind of slow, but the file system is also cached itself, right? And so I wonder whether there isn't like a shadow LRU cache um,
Mm.
that the file system just sort of gets you for free. Because like I'm almost thinking like, gosh, I mean, going out to disk for your cached, controller responses. That's kind of.
Kind of slow, but well, so that you're bringing up a really interesting point. You're leaving out something though, which is thinking about in terms of speed. If you've got it in RAM, well, that's pretty fast, right?
Mm-hmm.
Um, like this memory store, yeah, that's going to be super fast.
Mm-hmm.
But network calls compared to anything local are almost certainly going to be pretty slow. Like doing all that stuff over the network is probably going to be probably an order of magnitude slower even than the file store. I know the disk is slow, but it's not as slow as firing up a network connection, reaching out across the network and asking somebody else's disk.
Mm-hmm. Or
So
or God help you, like what I mean. What about where does it go in terms of like the database, right? Which the database has its own caching, right? Its own, I mean, its own fairly sophisticated caching, right? And it also like will catch updates that maybe a web server doesn't, what I mean, understand. I mean, like like something else could be updating a record, right? And the web server might not necessarily be like part of that process, right? Somebody you could have some delayed job somewhere out there, or some like like internal database hook that's updating something based on some other thing, right? Like so how does the file store compare to the database? That's I think my main question. Like so much of the sort of like data coherency and like caching and stuff like that, we just sort of like, in web apps, we just sort of push it off onto the database. Like let them think about
we
that.
do. Well, you're also pointing out something interesting. Part of the reason we do that
Mm-hmm.
uh, is that like this memory store is
Mm-hmm.
almost hands down way faster than any of the others.
Yeah.
And it's simpler, right? You don't have to go to the file store, you just store it in memory. So why don't we use this for everything? And there's a huge reason for this, and it's the reason we go to the database. But because this is faster. This is absolutely faster. It's
Mm-hmm.
our fastest option.
Right.
But
But
um, what happens if you ever want to scale and have more than one server? And everything's virtualized now. So when I say server, it's probably not a physical machine somewhere. You probably don't have a data center anymore with your machine that you own that you have to go in and do something. Although it isn't that times aren't those anymore. You
mm-hmm.
probably have virtual instance in the cloud somewhere.
Mm-hmm.
And what I said is probably false. You probably have a pool of instances. Some it's probably like Docker, so you probably have something in Kubernetes or some other containerized thing, or you probably have a pool of containerized pods or instances of some sort that are
Sure.
running on a virtual server. um, and if you cache like this, that cache is not shared between those pods.
Mm-hmm.
So you lose much of your benefit of caching, and your caches can become totally out of sync between those instances, which is also weird.
Right.
Uh,
Right.
this is so there's a trade-off. There's a trade-off here that's not described at all. If you decided to go with one huge instance that ran everything and had a you know huge amounts of memory, um, you're gonna have issues with handling more than one request because you've got a single process. You can handle one request at a time, which is bad. But assuming you only have one request and just need that one request a day to be really fast, well, this is probably your best option. But that's such a weird load that nobody does that.
It's true. Well, I mean, like nobody does it consistently. You know,
Mm.
like I can think of several specific loads where it's just like, oh yeah, no, this has to take 3 or 4 API requests per day. You know, we're like I'm only gonna run this like every 3 hours. Like I can think of some,
Mm.
but like generally
Yeah.
speaking, like the thing has to be a little bit more available than that.
Well, and let's talk about that extreme case.
Mhm.
You're going to take 3 or 4 API requests a day. If you've got something like that, it's probably returning some sort of summary data or report or
Mhm.
something like that. Right?
Mhm.
In which case, you might very well have been spending the previous 2 or 3 hours building up all that data and setting it up in memory so it's quickly accessible because it's some huge gnarly request that it has to go compile a bunch of stuff. You don't want your request to take 5 minutes every time it hits. You could very well be taking a lot of time in the background jobs to get something in memory so that when it does hit that, it's very fast. That's a totally reasonable scenario in my mind.
Okay, so what would one do? I mean, like, so I mean that's an interesting thing, right? I mean, like the thing about a cache, right, is because it is intrinsically a lazy memory structure, and so um, it's not going to prefetch the stuff. So let's say you've got your CEO wants to wake up every morning and have his coffee and look at a very expensive data analytics sheet, and it's going to take
Right.
15 minutes to pull all the data from all the stuff to say like, all right, I mean, here's your executive summary of everything, and he wants to wake up, just have his cup of coffee, and see how do we do over the last 24 hours. He cares about that. So if they want that, how would you set that up? Like, is there a way that we could fit this into a traditional caching regime? I know the standard way to do it is you just have a cron job that says like, all right, my CEO wakes up at 6 in the morning, 5, right? Let's say they're a gunner, right? Which they probably they probably are. They probably are, right? So like my cron job is gonna run at 4 in the morning. I'm gonna prepare the thing and have this executive summary ready for my CEO when they roll out of their bed. Bang, here it is, 5 in the morning. We're ready. We're good to go. Is there something, but that's like sort of like a proactive thing, not a cache which is intrinsically kind of like lazy loading. Is there a way to use the cache solution for that particular problem? Is there a way we could fit that in?
Well, that's an interesting point because, like by definition, a cache usually, like the meaning of the word, I believe, comes from like storing something,
Mm-hmm.
uh, okay, saving it for later. And if it's the first time they're seeing it, that's a little bit different.
Mm-hmm.
Although, to your point, there's nobody going ahead. This is a bespoke report for one person. In which case, there is no previous person who saw it,
Mm-hmm.
and that's an interesting. If you're thinking about cache as saving time between one request and the next, then that's not possible if you want to define it that way.
Mm-hmm.
Suppose if you want to think about the cache in a little bit broader terms, though, of having something stored because you've got it prepared ahead of time. People are doing long distance hiking or bike rides out through the desert. They will drive out in their vehicle beforehand and cache water and supplies. Or people who hike like the Appalachian Trail, they'll have a cache of supplies so that it's waiting for them when they get there. And it wasn't used by anybody else. I think that word caching is broad enough to capture that scenario. I think that's the scenario we're talking about here, right?
Well, I mean,
Where
so
you,
yeah.
you you want to use it, but you prepared it ahead of time. You
Mm-hmm.
took the time to prepare it ahead of time and have it stored so when you get there, it's just available.
Well, exactly, and that's kind of sort of like okay, in this like admittedly like kind of weird thought experiment that I'm coming up with. Like what I was thinking about here was okay, they have the executive summary, and it's a lot of calculation, right? And so if you wanted to apply a caching model to that, what you'd want to do is you'd want to have all of the you'd want to have like maybe this giant calculation um, parceled out in little dribs and drabs as the day goes through. So as my as transactions goes through, right, I'm making sales, right, and I'm performing this analysis, in little bits throughout the day, so that when my executive wakes up out of their bed and they come up, like, a lot of what they want has been sort of pre-computed, right, in more of a cache like behavior, as opposed to like just like a raw cron job process the report. Like I've been slicing up this task little bit by little bit as the day goes by, and so it would be more of a classical cache scenario, in that like little bits of it I just have to sort of accumulate the little bits and process it through whenever they roll out of bed and they want their stuff.
Well, you got an important point there. When they're looking at their report, every data point in that report is probably not truly independent. Um, they, so we got to imagine industry. So they're selling cars.
Right.
Or a lot of people use cars, so we'll say cars. Um,
Okay.
they, there's probably a number in their reports of this CEO. Say, we'll say she's waking up, she's jumping up, looking at this report. She's seeing um, a number of different things for the previous day. Well, a lot of those probably revolve around some shared numbers, such as what is the total number of sales yesterday?
Right.
What was the total dollar amount of sales yesterday?
Mm-hmm.
And those two numbers are probably going to be used more than once, because that number is probably going to be compared to what the sales were yesterday, and the sales a year ago, the sales a week ago.
Mm-hmm.
That dollar amount is probably going to be compared. So those individual numbers, while the entire report as a whole is maybe big, there's a lot of pieces of that report that are probably going to be used over and over again. And we may even enable her to be interactive, right? Doing a little bit of poking around, looking at numbers that we didn't pre-prepare, but a lot of the components of that were pre-prepared.
Right.
Yeah, that's absolutely, Cat.
Yeah, exactly. And so, um, yeah, having a good like durable caching strategy. It underpins like the functionality of the modern internet. Like, like we just couldn't make it without it. And if we go out and we look at like what I thought was really interesting, though. You were discussing. So okay, we have a whole cluster of web servers. Those are all nodes. They're all operating independently. If they're operating a memory store, right, their caching is going to be a little bit less efficient, because each node, right, each pod's memory store is going to be independent. You need to make sure that they're all coherent, which means, if I make a request to pod A and it caches it, but if I go out and I hit up, my load balancer and it sends me to pod C, well, pod A's cache is no good. I'm assuming that like the caching strategy is fundamentally correct, and like pod C is going to say, it's going to go back to the data store, right, make a change, right, and then pod A's cache is stale for this request, and then it'll get offloaded. But and so rather than being like incorrect, will just be slightly inefficient, right? And so if you look at 23 and 24 here, right, now we're going out and we're saying, oh, my cache store is a memcache store, and I'm going to have a host for it. I could have potentially a host that its job is just maintaining the cache, and it maintains the cache for the entire cluster, right? As long as that scales, right? And so this thing, all it's doing is saying, like, I'm a pod, I have a big old slug of memory, and I'm just gonna hold the cache for everybody, right? So like a little mini load balancer, right? Like a process, a server, then I am just doing memcache for this cluster, right? So I have a single point to check against and say like, okay, I'm managing this. Here we go. Um, and that's interesting. That'll get you to maybe another level, right?
Well, while we're talking about this, then we get down to this next one. Like that solves all the problems of now you have it shared, right? So you solve some of your cache consistency problems because you only have that single point. But then maybe you need to do your own thing. Why would you do your own thing? Um, I have some answers for that, having had to do this before. I worked for a content management company for a
Right.
long time, where we worked with publishers, newspapers, um, and newspapers care a lot about having their content fresh. They publish something, they want it to go out,
Right.
and so we did. You couldn't cache something for hours. Every time something new went out, uh, you wanted to clear. Well, you wanted to expire your cache, but there is a huge risk in that. We had some publications that got a lot of traffic. Some of them not very much, but some of them got a lot of traffic. And you have a homepage on a fairly popular publication. Um, it gets a lot of hits. And if every time somebody publishes an article, you just clear the cache for the whole website, you're going to do very bad things. um, because if you're getting hundreds or thousands of requests to that page a second, then as soon as you expire that cache, then you have maybe hundreds or, well, let's say it's super busy, everybody's looking at it. Let's say you have thousands of requests per second, um, all trying to view that content. Now they all have to regenerate it in parallel, all regenerating the exact same content. And that's a bad thing.
Mm-hmm.
Simply marking the content as stale is actually a really really bad approach in that scenario. You have a cache stampede, they call it, where the cache expires. And now you have all of these different requests all regenerating at the same time, all doing redundant work to each other
Mm-hmm.
because they're all now racing to get to be the first one. The way we solved that was what we called the that guy solution,
Uh-huh.
which is the first person to hit um, the stale content. We called that person that guy.
Uh-huh.
would would regenerate the content. In fact, what we did was actually a little bit tricky. We would actually serve the content, the stale content, to that person because we noticed that we were making the content load really slow for that person. Um, but what they would do is in the background, when that person hit it, we would regenerate the full content and then cache it. So that user would see the stale content, but unknowingly to them, unbeknownst to them, they would have triggered regeneration of the page they were looking at.
Wait.
And
Okay. How do you know? How do you know? So like I go to this page, right?
you have to lock. You have to lock it.
Okay. Okay. So I'm curious here because like that is not that's a little bit contrary to like your standard cache, right? Like your standard cache is like, okay, I've got this thing, right? Like I've got a page, right? Like, I've got a page, right? I cache the page, and then if somebody updates the page, they trigger sort of like a cascade of like cache failures to say like everybody, if you're caching this page, this is it's evicted, right? Like generally speaking, like I update the content, I trigger this broadcast that says, hey, this piece of content, this is no good. If you're using it, it's no good. And then the people that sort of like the people would be consuming that content, well, the cache would get evicted, right? It would be marked as stale, and
Just
then
you
there's
hit the key
nothing.
word. You said people. You're right. Every one of those people has to regenerate the content, which is bad. If under the high load scenario, that's actually a really bad scenario. Um, and it's just not viable. So in that scenario, you have to do crazy custom stuff. That's what we decided to do. That not people, person, the first person who hit that content stale would trigger a regeneration of the content in the background, and they still get stale content, so it'd actually go quickly for them. This little optimizations we made. They would get the stale content, but trigger regeneration of all the content, and this only works because we would have a lock on it, the ability to lock the cache. So the first person who saw it um, would saw it stale. There was I don't remember what mechanism. I think we used Redis or something to do some locking. So we had a guaranteed single point where we could do the locking, and they would lock that content and then generate in the background. And then everybody else, if they'd see that it was stale, but they'd also see that it was locked. So there was multiple conditions. You had to have content that was uh, either not yet expired or um, locked. In either case, you'd still see the content from the cache. But then you have another issue: is what if your background job to generate the content fails?
Um, yeah, yeah. I mean,
So you got to have a
presumably you would restart it, but I mean, I suppose like so like the scenario I'm thinking of. So okay, walk me through this one more time because the standard is to like okay, this piece of cache content is stale. We evict it from the cache, right? It's out, and then the next person that comes in, they'll hit it, they'll have a cache failure, and then you'll regenerate it that way, right?
right.
So that like I mean like the first person, rather than getting like stale content, right? Which maybe it's okay for a newspaper, right? Like okay, we posted an update or a correction, like the old stuff isn't bad, but if it's like a bank account balance, that's not okay. we
That's
can't
not
we
okay.
can't give you stale content. We can give
Right.
you so we will give you slow content, right?
Exactly.
You know.
And that's exactly right. And there's a trade-off there. If it needs to be exactly right, like a banking account, you have different constraints.
Hmm.
The interesting thing about the bank account, though, is you have presumably a small pool of people sharing.
Right.
Yeah, you maybe have 5 people max or something. You have a small number of people who are sharing that bank account, so
Hmm.
it becomes slow for 5 people
Hmm.
when you perform things when you perform any of these actions, which is a reasonable compromise, right? You're okay with making things slow, for having making those 5 people regenerate over each other.
Hmm.
But if you're formerly called Twitter,
Right.
um, and you have uh, 2 million followers of celebrity.
Right.
I don't know. Sorry,
Sure.
yeah, huge numbers of followers for that celebrity, and you expire that content. You have 2 million people now going trying to regenerate the content. You've got a bad situation,
Hmm.
and it's okay. It's okay in that scenario if and here's the trade-off that you're observing. It's not. It's okay if those 2 million people get get slightly different content for a little while.
That's true.
It's
Right.
okay.
Yeah.
They all exactly the same time. It doesn't. It's okay. It's maybe not ideal, but that's where you can choose to fudge things a little bit. By
Hmm.
relaxing that constraint, you can make it viable, because it's not viable for
Hmm.
those 2 million followers to make them, if they're all just refreshing the page because they have the latest gossip, uh, to have them all regenerated every time somebody posts their tweet. You're going to take down your site awfully quickly.
Okay, so effectively, if I can recap, right, the goal here, like what you do is you flag the thing as stale, right?
Mm-hmm.
You flag the sucker as stale. You sit back and you say, okay, I'm going to give you the stale page, and then I'm going to lock it, right? So,
Right.
so and if you dumped everybody out of the cache, right? So you just said you did what the standard thing was, like you would evict it. And let's say it's a high traffic piece of thing. Let's say it's like an election is going on and everybody is refreshing the page, or like a sports game, right? It's a Super Bowl and everybody wants to see the latest sports thing. So what you're gonna do, right, is you're going to like sort of like lock it and regenerate it, but you're not going to evict it so that you have a million people trying to reconstitute the cache, right? You're just gonna
Exactly.
you're gonna say like, all right, I'm gonna reconstitute this article, but I'm gonna reconstitute the article, but like in the meantime, you're gonna get the stale version because we can afford it, right? It's okay if your news is like 30 seconds out of date, you're gonna be okay.
Exactly.
And then you go out and you say like, okay, so you lock it, you start a job to reconstitute the article, right? When the job finishes, it updates the cache. I have a custom cache server, right? We're on line 25 here, so like this is like my
Right.
slightly stale day old bread is still good. You're gonna be fine. Cache, and then it updates it, and then it updates its own internal registry of articles, so that everything is more or less okay.
Right. And then once it's resaved it in there, now you've got fresh content. Everybody else just proceeds as normal.
Right,
But
but
having those tiers where you check both if it's current and if it's not locked is necessary in order to prevent those stampedes.
right,
Um, and
right.
then there's the third tier. There's the third tier that you have to deal with is what if your background job fails? Because everything will fail eventually. And in our scenario, we just had a timeout on that. If it's been, and I don't remember what exactly our timeout period was. Let's say it's been a minute. I think it was shorter than that. But if it's been a full minute and you haven't got your content yet, that something went wrong. And we just said, in that scenario, go ahead and let the stampede through. And it was rare enough that we never had a problem. Um, but if you were big enough, like you say, on that election,
Mhm.
it may be that if your background job fails, you want to run that again because if you've got that million people all trying to generate it once, you may take down your site.
Sure. Yeah, good old live lock. I mean, everybody knows about deadlock, right? Deadlock's fine, but like live lock, where your server is constantly being, I mean, you call it like a DDoS or a live lock or in a conversation when you're being shouted down because like no one can get a word in edgewise. Like that's a legitimate, like, for most standard programming kinds of things, you don't really need to think about it. But when you're in a cache situation, like LiveLock is a legitimate concern. You do need to let the underpinning data store server, like whatever, you need to give them enough time to finish the request, and a thousand duplicate requests because it's some high availability kind of a thing. Yeah, fair, fair.
And this is actually really interesting to take this further. I read once about how Twitter back in the day was handling this. It's probably they may have changed it since. Who knows what's going on there now? But in they actually maintained a list of high highly trafficked um,
Accounts.
publishers
Yeah,
accounts, exactly,
yeah.
accounts that were heavily followed.
Mm-hmm.
And for those, they did not follow the standard process. For those ones, if if somebody tweeted, one of these high traffic users
Mm-hmm.
tweeted, they would go. They had a process that would actively um, reset the data for the followers. So he would flip things around and like pre-generate the content because uh, the standard caching didn't work out very well for them. So and I don't remember the precise details, but they maintained a separate pool. They maintained a separate pool of those high traffic users and had it follow an entirely different process. So if you're following, um,
Taylor
what
Swift,
are the
right?
yeah,
Beyonce,
yeah, if you're following Taylor Swift, okay,
right?
good, that's a good example. Following Taylor Swift, um, you're seeing a totally different process in the back end than if you're following your buddy. It just they used an entirely different route through the code because the constraints were so different. Because when you're talking with your buddy, then the bank account rules probably work fine, right?
Mm-hmm.
You
Mm-hmm.
see it is stale. You you know you have to go and regenerate the content, and it caches it for everybody else, and it's fine.
Right.
So bank account rules apply to the small tier, but then for the heavy tier, they had to apply a totally different set of rules where they was like pre-generating the content rather than letting the standard caching mechanism apply.
Mm-hmm. See,
It's
anytime you open up Pandora's box of caching, things will be interesting, right? So let's keep on pulling. Mark, did you have anything?
No, no, I was just finding it funny listening to all the caching because you don't hear you don't hear about caching often.
You don't? Like
No, I
caching
don't.
is caching is the boogeyman of every senior developer.
Well, it's a good thing I'm not a senior developer.
Well, it's the famous quote, right? That there's two hard problems in computer science, um, and the first one is cache invalidation.
No, no.
Because it,
It was always. I always heard that there was a. The joke is this, right? Like, there's two hard problems in computer science: naming things, caching, and off by one errors.
right. But cache invalidation is one of the three, one of the miscounted two.
Yeah, yeah, yeah. Uh, yeah, man. No, caching is the devil itself. Like, well, because I mean, so okay, so I mean, like I'll say like like okay, so like let's talk about scaling, right? Which is like the definition of a first world problem. But if you got the problem, you know what I mean? Like you better hope you got $100 bill to dry your tears because they are coming. um, so okay, so like okay, you could sort of see the descent to madness, right? Like in that, like okay, 21, easy peasy. Listen, I got this thing, it's going. I need to have a little bit of cash, right? I need to have a little bit of cash because it's starting to hook. Things are starting to work, right? Oh, I'm just gonna do memory store, right? But okay, well, what happens then? It's like, oh, well, maybe you need a couple of different pods. Maybe like you're running out of memory, right? It's like, okay, let's go to the file store, right? Okay, the file store. Or, you know what I mean? And maybe we have a shared drive. Okay, but it's like I need more speed, right? Because like going out to the file store is too big, it's slow. Like the file store is really not, set up to do this kind of thing. It's like, okay, I'm gonna do my own memcache thing, right? Right, where because I need like a for real cache. I can't just dump it on the disk. Like I need a better solution. Okay, now I have a memcache thing, right? But now I have the same set of problems, like because I have a cluster. You know what I mean? And now I have a dedicated memcache store, right? Okay, so we talking about like sort of like a bespoke problem that Mike had, but like, well, what if I have like what if it doesn't fit in a single memcache store? Like I've got a dedicated pod for just memcache, but like what if I need two? Now we got all kinds of problems. Now we're trying to shard things across data centers. Now we're trying to maintain like you hope it's just one data center, but what if I got East Coast and West Coast? What if I got Europe and Asia? Like, okay, now we're you can see how the whole thing, descends into nightmarish complexity, trying to keep things straight between, Salt Lake City, Utah, and Singapore, maybe it is a bank account. Maybe, yeah, no, maybe it is a bank account, and we need it all the way right. Now, this eventual, like, sooner or later stuff, this won't do anymore. So anyway, I mean, you could just see how things sort of
Oh
descend
yeah,
into madness.
like you say. And what if you are having a huge amount of traffic? Your cache, one of those cache servers, one of your five caching servers that you've got, geographically distributed, goes down, your whole site goes down because you don't have the CPU in order to to regenerate it. You're depending on that cache. Now you have to maintain multiple copies of that cache,
Mm-hmm.
preferably geographically distributed,
You hope.
and keep those in sync with each other.
Mm-hmm. And what if you have a network bisection? What if that network goes down and then one of your data centers goes down, right? Is it gonna take everybody else down with them? You know what I mean? Like is it gonna vomit errors? You know what I mean? And DDoS, from the inside because like this data center's gone down, this cache thing has gone down, or is it gonna just sort of like, you know, quietly choke and then everybody's load just goes up by like, say like you've got 3 and everybody's load goes up by 30%, which is okay probably, it's not great but it's okay. Or is it gonna cascade failure and like, make everybody's load go up by 300%, in which case, you're gonna have it start shutting everything down. It's just, I think Netflix, they had they had a big paper that they described their sort of like site reliability team had a tool that I believe was named affectionately, I'm sure, Chaos Monkey, which just ran around shutting things down. Where it's just like, all right, like let's just have it kick the plug out of the wall and see what happens. Make sure that.
And that's a fascinating story too, because can you imagine walking up to your boss and saying, "I'm going to write a malicious bot that's going to break our stuff all the time, and I'm going to leave it running."
Mm-hmm.
And the boss says yes. And the thing is, they did say yes because the alternative was that they never tested their failure scenarios. There was no failover testing.
Mm-hmm.
And by guaranteeing that they were doing failover all the time, they got that thing hardened. And it became exceptionally reliable. It was only by forcing stuff to break that they were able to get the reliability that they needed for when stuff broke accidentally.
That's the truth. I mean, yeah, and I mean, like that's it's gonna happen. Like it will happen. There's no getting around it. Anyway, so yeah, I mean, I think there's so there's some other stuff here because like we were looking at this as like, oh, this is really easy, but I actually think so module caching, right? So now we're getting into the meat of it, right? First one's a namespace. Now we're going to get into caching. We're going to extend active support concern. And Mike, correct me if I'm wrong, extending active support concern is just sort of like, that's just sort of like plumbing attached to like, you know what I mean? So it isn't just a straight up like module include, right? There's some convenience stuff there. Do you remember?
And and the main thing that the concern gives you is that when you include something, you're including it in that particular scope. And think about the scope here. It's extending here, right? Within this module's scope. So it's all happening within, within this context here. But what if you want to add a module level method? When you're including this module, what if you want to add a class method? What if you want to add an instance method? Those are different things, right? Those are different scopes.
Right.
And you need to handle those differently. So this concern just gives you a little bit of plumbing for making that easy so that you can put the right things in the right scope and it's defined. Okay.
Mm-hmm. So here we've got, right, so here we've got like in line 29, so I actually think this might be a little bit of a red herring because right now what we're doing is saying like included, now we're including abstract controller caching right into our stuff. And I don't know, like, I don't know whether that might be like kind of intense. Abstract controller caching. So if you look at that left bar, right, there's abstract controller just above action controller. Just above the directory, just above. Yeah, there you go.
There it is.
Yeah, caching, right? Fragments? Abstract controller
Here it is.
caching.
Here it
Okay,
is.
yeah, because like this stuff is kind of, I don't know. I didn't think I was gonna get out that easy. Yeah, here we go. Yeah, so now we're gonna get a little bit more interesting, right? So abstract controller module caching extends concerns, extends auto load, right?
Right.
Eager auto load. Okay, so once more, I'm going to do a trust fall on Mike's extensive Rails in expertise.
Well, this one, we're talking about caching. One nice thing you can do in Ruby is hot load code. That is, um, you don't have to load all of the code at because it's an interpreted language. You don't have to compile it all at compile time. You can have some code that isn't yet loaded into memory when you launch your app.
Got it.
And they've got a whole system for auto loading on demand. So you don't even load the code until you mention it. And for local development, that can be a real benefit because you don't have to pay the cost of loading everything into memory when you're restarting.
Right.
It allows you to get up and running and start going because you're probably not exercising your full app
right.
when you're just doing local.
Mm-hmm.
So it saves you a lot. However, that comes with cache related issues, right? Because if you don't have something in memory, you could think about code being loaded to memory as a form of cache, right? You've loaded into memory, now you're going to use it.
Mm-hmm.
You've got to deal with the fact that sometimes stuff has to be in memory, or else you're going to have some issues when you try to load it and it's not there. So and I don't know the exact details of why they would need to do this here, but they said no, we're not going to do this lazy. You're gonna go and you're gonna load this into memory no matter what.
And so we're gonna auto load fragments, the symbol fragments, which I assume is going to be the fragments. So where do we learn what fragments is going to tie to? Is that's a so auto load fragments and abstract controller caching. So we're in this is a little bit like kind of like Rails plumbing nitty gritty stuff, but like so I'm in abstract controller caching, right? And I see the namespace, right? And I see the fragments, and I know if we open up that caching directory, we've got a fragments.rb, right? Like just first one in abstract controller in that left bar, right? We've got caching fragments, abstract controller caching, yeah.
I'm not saying it.
No, up one. So we're in sort of like abstract controller in the subdirectory there. Open that one up. Down there. Open caching. The caching drop down. It's above rail ties. It goes abstract controller, caching, rail ties, and there you got fragments, right? I'm slightly curious about so here we go. Abstract caching, fragments, extend. Oh yeah, see, yeah, we're getting all kinds of weirdness in here. I mean, not weirdness, but like
Well, so a similar sort of pattern all the way down.
Right, and then and so here we're including when it's included. Run this block within the context of like whatever class, right? Like whatever class we're included into.
Do it as a class. If it's a module, do it as a module.
Okay. And wait, so if respond to class attribute, does that mean, is that just sort of like a side loady way of saying like, am I being included into? Maybe I don't. I actually don't think I understand this one.
So this one's interesting too, because this anybody who doesn't know Ruby, this is an anonymous function, and it'll get run later. And the scope that gets run in is going to be a little bit funny. It's going to be able to check where it's included if that particular scope it's included into, if it has a method called class attribute.
Right.
And this is checking. Normally, you think, well, it's asking if it's in a class. But it's doing this in this way, I think, for a reason. That like, what if you've done something really crazy and you're actually including this um, into some bizarre uh, amalgam
Well,
of module and class that you've created. As long as this is defined, it can use it and treat it like it's a class.
right. And so we're just saying we're creating a class attribute called fragment cache keys, and I think matter is like if it's a module, right? Not a class, but it's a
Right.
module, and
Right.
then we're gonna say, okay, I want to have a module attribute. You know what I mean? Like a global module level attribute that's fragment cache keys, so that you know what I mean. You can, and then once it's been set up, you set it to be an empty array. Is that is it an empty array or is it an empty
Right. That is an empty array.
fragment cache keys empty array? Interesting. Okay. Right. And then we say if respond to helper method, we're gonna make a helper method which is combined fragment cache key. This is a little bit interesting to me, like helper method, because we're not providing any kind of like implementation of the thing. So how are we?
Well, then they're going to add this combined fragment cache key. That's probably there. It is right there. So it's going to make it available as this helper. So it's going to take this method down here, and it's going to make it available, kind of like a different as a again, this is more of a scoping sort of thing. It's going to be make it available in a different scope than it would be. It's not that it's moving the scope, it's making it available through a different scope, so that you can access it through like an API more or less.
Okay, and if it was not done like that, how would you have to access? Right. So
So it would be available just as this method within the
module.
looks like, let's see, it's not in the class methods, right?
Oh,
So it's outside of there. So it's just this instance method that you can call. But sometimes you want to be able to make these accessible to like a template that you're sending some data to, which is pretty common for the stuff where you're looking at these controllers. They normally associate with templates and REST, templates we call views, and you want to be able to provide some of these methods to those templates, but you don't want to make every method available to the templates. You want to have a list, right? You don't want to say, hey, you can see all of my private business. Like, no, no. You want to explicitly specify which methods you're going to be making available to the template. And that's what this is doing. This is saying, hey, that template, that's going to be able to access this because it needs to be able to see some of your business, but only the business you told it can see.
okay. So the class methods by definition um, it would be private. I feel like you include a module and it doesn't become, you know what I mean? I feel like when you include a module, it isn't intrinsically private. I mean, like I know I've
Yeah,
included modules into a class where it's, you know
right.
what I mean?
There's public. And when I was saying scope, I wasn't thinking about public versus private, but rather um, like a class level versus instance level, which
Okay.
are two different variable scopes, right? Like one of them is taking place. They call it like the static scope in Java, or another language they call it static. In that it's not located within a specific object,
Right.
but it's located at a higher level, and that's the
Right.
class level.
Okay. And so if you have like a view template, then because the view template, only has access to like the view template doesn't necessarily know the class structure of the containing controller, right? So it just gets the controller and then it says like so that okay. So it's effectively kind of syntactical sugars so that you can access the class method directly from the instance of the class without jumping through like, self.class and then doing it that way.
Right, but it looks like it is an instance method. Like it's not fragment cache key; it's combined fragment cache key, which looks
Right.
like it is actually instance level method. But um, there's a whole API inside Rails to make some methods available without prefixing them within your templates. So this would make that method available in that way. So in your template, you can just call combine fragment cache key. You don't have to say controller.combine fragment cache key. You just say combine fragment cache key, and that method is available as if you were calling the controller even though you're in the template.
Oh, yeah. Okay. I get it. Right. Because, like, yeah. So, because the controller, the Rails controller, this is me just being sort of a polyglot. But somebody, if anybody's watching this, you know what I mean, and they're less familiar with Rails, it might be useful to them to, like, watch me struggle. But, so, yeah, because the Rails controller just copies a bunch of stuff up to the Vue template. Right? Like the Vue template gets access to all like the instance variables, right, from the controller.
But it also gets the methods.
Some methods, but not all. And so that helper method is, yeah, it's tagging this method to say like, okay, yeah, this one goes over, right? But it isn't taking everything because it would be both inappropriate and inefficient. And so,
right.
Got it.
We're at time also.
We are at time. That was a great talk. I like this. This was fun. We could do. I love Stack Overflow questions. And so the big like maybe one to go on question that I've got for you guys is advent of code is starting soon. I don't know. We can think about like how we want to maybe like if. First off, if, and second, like how, we what do you call it? We sort of we manage it. I don't know if I want to do them live necessarily for the skills clinic. I don't know. Like we tried it, and I don't know. Like I suppose like anyway, we'll think about it and come up with your ideas, and.
Be available next week.
What's that?
That'll be available next week.
It will be available next week. I really enjoyed today's deep dive into Rails internals. Like, I like the Stack Overflow questions. I would love to. I think the Rails caching thing is at least a two-parter. I don't feel like we did this one justice. This one's deep, and we're only really starting to. Peel back the layers of the onion.
Oh yeah, we barely touched how the code works at all.
I could do another week on this one, pretty happily. Anyway, well, it's a thought. You guys know how to reach out to me. Just holler at me. Let me know what you think.
Yeah, and Mark, why don't you think about it? What do you like more? You want to go through some advent of code, you want to go through Stack Overflow, you want to dig down into Rails internals. You don't have to answer that question right now.
I actually already have an answer. I think if we do advent of code, I think we're going to repeat the same problem we had before we started going over Stack Overflow questions, which is advent of code. Like maybe some of the first few advents of code will work, but the more we get into advent of code, the more complex it will be, the harder it will be to stay involved.
One thing that's true though is we'll have 4 sessions in approximately 3 or 4 sessions in December, so we're only probably booked the first 3 if we get even through those.
Right. Well, I think maybe one thing that might be interesting is like rather than live coding it. Or honestly, live coding it separately. You guys can hop on Twitch anytime you feel like it and like, live code something. There's nothing saying you couldn't. Welcome to do it. what do you call it? Maybe the group sessions could be more about sort of reviewing implementation, saying like, hey, this is what I did. You know what I mean? Like, or if you got stuck, if you have a question, what could we do to get over this hump? I know. As it goes on, they get pretty tricky. Um,
They do.
so anyway, so it might be interesting. There's different ways to skin a cat. Um, purely for my own like sort of stuff, like pulling apart Rails has been really interesting, just because like there's a lot of interesting high level work that you just barely have to scratch the surface, and the infrastructure and internals of Rails start to get really interesting and fun, in my opinion at least. I'm a little bit of a masochist.
Yeah, no, you start seeing interesting stuff right away.
Yeah.
All of the how to think about variable scope, um, and what that means, and why they have to think about that.
Mm-hmm.
It's in the face, right up front. There's not something you think about most. Like you think, I mean, you have to learn it. Something variable, local to your function.
Mm-hmm.
But
Mm-hmm.
thinking about how to grapple with that explicitly is
Mm-hmm.
not something you do.
Yeah. Well, cool. Anyway, it's been a pleasure. Um, see you guys all next week. I'll get this thing up. I'm gonna start I've been recording these things so I can put them up on YouTube, because Twitch deletes them, and I'm a digital hoarder. I don't like them. I don't like them deleted. You know, like they last for like a week and then they get tossed. I'm like, no, no, no. This is for the ages. This is gold. This is as good as it gets right here. This is like a TED Talk every week for free, or for freer. All right. See you guys.
See ya.
Yeah.